site-to-site VPN connection in the Azure portal. So today we are going to see how we can connect on-prem data center with Azure cloud using internet as the transport, right? Internet as the transport, not express route. Express route is very much like point-to-point dedicated lease circuit. Already we have discussed about express route VPN in theory session. So today is lab session. So straight away I will take you to Azure portal and will show you how we can create VPN gateway, local gateway, IPsec tunnel configuration in cloud first, and then configuring on-prem VPN gateway appliance, right? So for this lab demonstration, I have Palo Alto Firewall running in virtualized environment EVNG, right? With one test PC, computer behind Palo Alto Firewall, network address 10.1.1.0/24. In Azure Cloud, I'll create a virtual network with two subnets. One subnet for servers or virtual machines, resources, and another dedicated subnet for VPN gateway, right? And name of that subnet would be gateway subnet. So two subnets in a virtual network, and once infrastructure is ready, virtual network is created, two subnets are created, then straight away we'll first spin up virtual private gateway, in Azure cloud, and then another resource or object, that is local gateway, right? Local gateway is to define or map on premises VPN gateway. So two different gateways would be created in cloud. First, VPN or virtual private gateway, and then local gateway. Local gateway is to define a map on-prem VPN gateway. It's very confusing because if local gateway is basically local to on-prem data center, right? For Azure, of course, gateway is remote gateway, a remote peer, a VPN peer, but in Azure, we create local gateway object to define on-prem VPN gateway, not like remote or peer VPN gateway, or maybe peer VPN gateway. A bit confusing, of course, right? So a lot of students get confused with local gateway. What is local gateway? So local gateway is nothing, just uh, mapping your on-prem VPN gateway, right? So virtual private gateway, local gateway, once both gateways are successfully created in Azure portal, then the third step. So first step, we are creating virtual private gateway in cloud, then local gateway, local internet gateway, and third step is configuration, means creating IPsec tunnel, right, between on-prem Palo Alto in this lab topology and Azure VPN gateway, right? And once all three steps done successfully, virtual private gateway created, local gateway created, tunnel is configured, the next step would be downloading configuration file, right, in Notepad. And what was the purpose of configuration file in Azure? So basically in configuration file, we find IKE attributes or parameters, IPsec attributes or parameter, routing configuration. So complete configuration in the Notepad file. And you understand, whenever we set up IPsec tunnel, then parameters attributes, security attributes should be identical, should match, right? Local gateway parameters should match with the remote gateway parameters, right? So for that purpose, configuration file is generated in Azure portal, we can download that configuration file and then we can start doing configuration of local VPN gateway, right? So whatever information would be required, like phase 1, phase 2 parameters, routing, IPs. So we would retrieve those information from the configuration file and then we'll start doing configuration of Palo Alto Firewall. I hope like this lab topology is clear to you now and you understand like what is lab objective. Objective is to set up IPsec tunnel between on-prem data center and Azure cloud so that servers or computers behind Palo Alto Firewall so communicate with resources or virtual machines in Azure cloud with private IP address and using internet as the transport, of course, right? Using internet as the transport. We are not going to use any dedicated lease circuit or express route. Internet is the transport here, internet, right? And why do we need then secure tunnel? Just to provide secure connectivity, secure communication between on-premises network and Azure cloud for security purpose, for data integrity, data encryption, right? Data origin authentication, anti-replay. We need to configure IPsec. So straight away, I'm going to uh, take you to Azure portal and I will first create virtual network with two subnets. One subnet dedicated for VPN gateway and another subnet for virtual machines or resources like maybe servers or some other resources, right? All right, so it's my Azure portal account. Search for virtual network because I want to start with virtual network. So as I mentioned, like first step, create virtual network and 172.16.0.0 virtual network, and I will give vnet 01 name and address space 172.16.0.0/16. Create two subnets in vnet 01. One subnet like gateway subnet for firewall, VPN gateway, I mean virtual private gateway 172.16.1.0/24, and another maybe my private subnet. I can give any name, right? It's just the name, private subnet 2.0/24, not connected with internet. Third step, create virtual private gateway in gateway subnet, of course, and will take time, approximately 30 to 40 minutes, right? Minimum 30 to 40 minutes. Create local gateway to define or map on-prem VPN gateway, right? In my lab, in fact, I'm using Palo Alto Firewall here. And step number 5, create IPsec tunnel. It's like this configuration, tunnel configuration. Step number 6, download VPN configuration file. Done. So Azure portal side configuration done, right? Configure on-prem VPN gateway And once done, then just do verification and testing. Verification and testing. And for that purpose, even also spin up virtual machine in private subnet, right? For testing purpose. All right. So first thing first, create virtual network in any region. A new resource group, my resource so vnet01 is the name, address is space. I want to go with 172.16.0.0/16 major network. Add subnet, two subnets. So first, let me start with this gateway subnet 172.16.1.0/24, and name should be gateway subnet, right? G is in capital, S is in capital letter, and one more subnet, private subnet 172.16.2.0/24. So virtual network with two subnets. Review and create. So first step is creating virtual network with minimum two subnets. One subnet dedicated for virtual private gateway and another subnet for virtual machines or servers, right? Next step, like virtual private gateway. Create virtual private gateway in gateway subnet. And step number 3 will probably take 30 to 40 minutes. So in the meantime, what we will do, we'll just perform initial configuration where on this Palo Alto firewall. So what I will do, I will configure Palo Alto firewall, right? In the meantime, initial configuration means like creating security zones, assigning interface IPs, default route, maybe security policy also. Okay, and Palo Alto firewall not necessarily should be assigned a static public IP address. Even like if there is a private IP address assigned to external interface, no problem whatsoever, right? We can use private IP even if there is a NAT device in front of your firewall, VPN gateway, maybe your home broadband router, Wi-Fi router, any other router, no problem, right? We can set up IPs external. But yes, public IP assigned to your home router, broadband router, maybe Palo Alto firewall external interface, that should be, of course, public IP address, right? But in my environment, in fact, there is a static public IP address, fixed public IP address not assigned via DHCP server. But even you can use DHCP assigned IP address also for your lab testing purpose. So virtual network is successfully created with two subnets, one gateway subnet, another private subnet. Next step, home, search for virtual private gateway, right? Virtual private gateway means virtual network gateways, right? Virtual network gateway is basically your VPN gateway in Azure. So what it does, connects your on-prem networks to Azure through site-to-site VPN in a similar way that you set up and connect to a remote branch office. Connectivity is secure because of IPsec protocol suite, IC and IPsec. You understand theory well, right? So I don't have to repeat that theory again. Virtual network gateway. Select your subscription, name it your Azure VPN gateway. You can uh, give any name. Reason, gateway type is VPN, of course, not express route. And VPN type, there are two options here: route based and policy based. So modern way of configuring VPN is what? Route based, not the policy based. Policy based is a legacy or traditional method. But what's different between route and policy based? So in route based, what happens? Routing table is used to make the decision whether packets need to be tunneled, encrypted or not. Right? Means if there is a VPN gateway device, a router or firewall, any device, okay, so request packet, here's the gateway. So gateway checks the routing table. Do I have route for the destination? If yes, then what is the exit interface? If the exit interface is tunnel interface and tunnel is protected with IPsec, then packet is put inside the tunnel, encrypted and all that, right? Treated with this IPsec framework. And if like next hop IP is our exit interface is other than tunnel interface, then packet is just sent to the device, right? So that's what route base is. Means no proxy ACS, no policy. So route base, even like you can do dynamic routing, you can run border gateway protocol, or maybe some other. In Azure cloud, of course, we can do either static routing or border gateway protocol. No other routing protocol is supported here between production network in like your physical network environments. Even you can run OSPF or any other protocol if you are using route base, right? And Palo Alto primarily, yes, is a route based VPN. Even we do have option to mention like proxy IDs, but primarily a route based VPN configuration. Cisco router supports both route based and as well as policy based VPN. In route based, we create GRE tunnel, then tunnel is protected with IPsec. In policy based, what we do, we create an access control list. So traffic is matched with the access list, right? And if traffic matched with the ACL, then only encryption is done. Not matched, then no encryption. Okay. Cisco traditional ASA firewalls support only policy based VPN. So modern way is like configuring route based, but even route based VPN minimizes phase two tunnels. I mean, like if there are multiple networks or subnets that need to be protected behind a VPN gateway, right? So for data tunnel, only one pair of tunnel is required, is created, only one pair of tunnel, no matter like how many subnets or networks you want to protect with the VPN gateway in route based VPN. That means number of phase two tunnels, only one pair, irrespective of number of subnets or networks that need to be protected. Whereas in policy based VPN, phase one tunnel, that is your management tunnel, is of course only one tunnel, but phase two tunnels, right, would increase with increase in number of subnets or networks. So if there are four network pair, five or six network pair, accordingly there would be phase two tunnels, right? One pair of phase two tunnels for one network or subnet pair. So that's another reason why policy based VPN is not like used in modern day VPN configuration, because increases number of phase two tunnels, dynamic routing is not supported, and whereas in route based VPN there is no problem, right? You can run any routing protocol, only one pair of phase two tunnels, irrespective of number of subnets or networks. And then stock keeping unit, VPN gateway into AZ or single VPN gateway, right? So like if you want to like use like two AZ like availability zone, yes, pricing would be different. Better like to check the price. It's all about the pricing and of course performance plus high availability, and then generation, right? Generation one I want to go with is lab environment, and asking like virtual network. So virtual network already created. Select your virtual network. Look at the subnet selection here. Automatically, a subnet, gateway subnet is selected, right? Because of this naming convention, gateway subnet. All right, public IP address. Yes, I want to create. So it's my VPN public IP. You can give any name here. In which availability zone? So only one. Active mode. No, we don't want to go with any BGP or active mode configuration. Even Microsoft Azure and even AWS cloud computing providers strongly recommend setting up two tunnels, IPsec tunnel, right? Two tunnel 1 and tunnel 2, but not mandatory. So even if we want to do testing with only one tunnel, that's good enough. Okay. So go to the next step, review and create. Now next, create. So virtual network gateway creation takes approximately 30 to 40 minutes, right? Local VPN gateway doesn't take much time. And once both gateways, virtual network gateway, that is your VPN gateway, Azure VPN gateway, and local gateway, means like your remote gateway, both gateways are created, then we can go ahead and do like rest of the configuration, creating like tunnel and all that. All right, so virtual private gateway is like is in the process of deployment, and here known as virtual network gateway. So it's a VPN gateway basically. Local gate to define on-prem VPN gateway, Palo Alto. And at the time of creating local gateway, you will be asked to input like your on-prem VPN gateway public IP, right? And also local subnet or network, right? Networks are subnets behind Palo Alto Firewall. So if you look at this topology, so I hope you understand. Let me clear. So public IP is 122.176.108.99. And what about internal network? 10.1.1.0/24, right? So I'm going to open a duplicate tab because my objective is to create local gateway object also. So virtual network gateway and local gateway. Once both gateways successfully deployed, then we can do rest of configuration. So search for local gateway, local network gateways rather, local network gateway to represent the on-prem site that you want to connect to virtual network, right? So basically IPsec tunnel is terminated to VNet, virtual network. But what if you have multiple virtual networks in the Azure cloud? So do we have to create multiple IPsec tunnels, right? If you have more than one virtual network in cloud, because tunnel is terminated where? Virtual network. So what if you have multiple uh, virtual networks in the cloud, right? So what then we do? We first like create here hub and spoke topology. Hub and spokes means hub virtual network and spoke virtual network. So IPsec tunnel is always created between on-prem VPN gateway and hub virtual network. So this way we can reach out to different virtual networks already connected with peering connection, of course, with the hub network, hub and spoke topology. And if you don't do that, if there is no hub and spoke configuration in the Azure cloud, so then you would have to set up IPsec tunnel with each virtual network then. Not very scalable solution, because if there are 5 virtual networks in the Azure cloud, So obviously we would have to set up 5 IPsec tunnels, not the best practice. So best practice is always setting up tunnel with a single virtual network, and other virtual networks should be connected with the hub virtual network with peering connection. So if transitive option is enabled, means your hub site is transitive, then yes, we can reach out to different virtual networks via hub VNet. It's a bit complex topology, but if you are interested in, then even you can configure that also. So it's a local gateway. I will select my resource group here. My resource group 1 name, I will name it Palo Alto Firewall so that I can easily recognize. I'm asking for the public IP. So what is public IP? 122.176, 122.176.108.99, 108.99. And address space means private network or networks behind Palo Alto Firewall, right? So there is only one subnet, that is 10.1.1.0/24. And why address space is required here? Because in Azure cloud, routing table is automatically modified. Once tunnel is up, then routing table is automatically modified, because you understand, even like after a tunnel, IPsec tunnel, so internet is the transport. Tunnel is created between Palo Alto and Azure VPN gateway. But what about the routing? If let us assume 10.1.1.2, this guy wants to communicate with 172.16.2.4. So client request, here's the Palo Alto firewall. So Palo Alto firewall will check the routing table first. Do I have route for 172.16.2 network or not in my routing table? Right? Definitely there should be a route with exit interface, tunnel interface. And tunnel is protected with IPsec. That means communication would be very, very secure. So do we have to do routing? Yes. And that's what route-based VPN is. What about the cloud side, right? So as we know very well that in Azure, when we create virtual network and subnets, so a routing table is automatically created, and with plenty of routes in that routing table, known as system routes, right? So, but when we set up IPsec VPN tunnel, we don't do anything in routing. Route is automatically added in the routing table. Means if we have already specified private network behind Palo Alto firewall, that is 10.1.1.0 network that need to be protected. So what Azure does, automatically puts that route in the routing table with exit interface, tunnel interface. That means we don't have to modify routing table in Azure cloud. Routing is done automatically, and that's the reason why Azure is asking about address space, your internal network that you really want to protect with IPsec tunnel. Good so far? Understood? And you can specify multiple addresses here, right? Because there can be multiple subnets. So head down, advanced, configure BGP. So if you want to configure border gateway protocol, you don't want to do a static routing, and why you would prefer border gateway protocol in what scenarios? So let us assume you have multiple networks or subnets, a very large data center in Azure, also like multiple virtual networks with too many subnets, and really you don't want to do routing statically, manually, right? You want to advertise your connected networks, subnets, or maybe non-directly connected networks or subnets with routing protocol. So border gateway protocol is the only routing protocol supported in Azure, apart from static routing or default routing. So in case if you have multiple networks or subnets, really want to set up BGP peering, you can do that. Boundary Gateway Protocol is supported. We are not interested in BGP configuration. Just go to next and review and create. So create VPN gateway and local network gateway. Local network gateway. Okay. So only one last step is remaining, configuration part. And once configuration is done, then we'll download VPN configuration file, because with the help of a script, a config file is automatically generated by Azure. We can download that file so that we could know like what encryption method is, hashing method, Diffie-Hellman, DH group, security association lifetime, parameters that would be required uh, to configure IPsec, right? If required, then even like I phase one, phase two parameters or security attributes can be customized. Okay. So local VPN, local network gateway is successfully created. Just it took a minute or not more than 1 minute, in fact. But what about this virtual network gateway? Still, deployment is in progress. Takes time, right? Approximately 30 to 40 minutes. So let me. So it's my on-premises network infrastructure, right? On-prem network infrastructure. This one. Palo Alto Firewall for testing purpose. There is one computer connected directly with Palo Alto, right? There can be, of course, a switch and then multiple end host devices connected to the switch. And it's a brand new firewall. There is no configuration, nothing. So we'll have to start from the scratch. So, and already VPN gateway deployment is in progress. As I mentioned before, like takes time. So we can utilize that time in like doing some initial configuration on Palo Alto Firewall. So TCP assigned IP is 1.12, and I don't have to do anything in the CLI, because now there is like DCP assigned IP, management interface IP. So straight away I can access GUI page of Palo Alto Firewall, because we are not learning Palo Alto Firewall in this training session. So I don't want to talk much about Palo Alto, because they can be like maybe Cisco router, ASA firewall, checkpoint, FortiGate, right? So mainly we want to focus on Azure cloud. In fact, on-prem VPN gateway configuration, of course, depends like which vendor appliance you have in your environment, Palo Alto or Checkpoint or FortiGate or Cisco routers. So IP address is 1.12. Certificate warning message. So whenever we log in first time to Palo Alto Firewall, then we are forced to change the password at first login. If we are using like Palo Alto PAN OS version 9 onwards, so old password admin and now new password. So, so first I'm going to configure both interfaces and like Ethernet 1/1 and as well as 1/2 external and internal both. So you can look at this diagram also. So external interface IP 192.168.1.101. Public IP is not assigned to Palo Alto Firewall. Basically, Palo Alto Firewall is connected with internet router, and internet router has like one private and one public IP address. NAT is also configured. Okay. So as I mentioned before, like you don't have to assign public IP address directly to your Palo Alto Firewall. So even if there is NAT device in front of Palo Alto Firewall, you can set up IPsec internal. If you there is any issue, then even we can enable NAT T, NAT traversal. So, uh, so there won't be any issue. All right, so internal and external interface. So I'm going to start with Ethernet 1/1. Ethernet 1/1 is internal and layer 3 interface mode. If you are not coming from security background, you don't know much about Palo Alto Firewall, so your job is almost done once you have finished doing cloud side configuration. And what is cloud side configuration? Like creating virtual networks, subnets, deploying VPN gateway, that is virtual network gateway, creating local network gateway, and then finally IPsec tunnel configuration. Once you have finished all these steps, then just download VPN configuration file and share with your security team, on-prem engineer, like who would be responsible to manage on-prem VPN gateway. So if your job is just to manage Azure cloud, so your job is done, finished. Once you have finished like 6 steps, your job is done. Just download the VPN configuration file in Notepad, share with on-prem security engineer. Rest of the configuration, on-prem engineer will do, right? Because on-prem VPN gateway could be any vendor appliance, okay? Not necessarily even Palo Alto Firewall. So your job is done if you are responsible for cloud only. But if you know like firewall also, you are managing your on-prem infrastructure also, and if you are very much comfortable with Palo Alto or whatever like VPN gateway appliance your organization would have, then yes, like you can do configuration on local gateway also, and that's what we want to do here, because we want to do like verification. We want to verify the configuration whether there is proper connectivity between like on-prem machine computer and virtual machine is pinned up in cloud with private IP address and secure communication using internet as a transport, of course, but secure communication, right, with private IP. So that's what our objective is, doing proper verification. That's why we are also going to configure on-prem VPN gateway, that is your Palo Alto Firewall. So layer 3 interface, and quickly I'm just going to configure Palo Alto Firewall because Palo Alto Firewall is like, of course, out of scope. So I will not spend much time here. Inside security zone, IP address, want to assign 10.1.1.1/24. IP is assigned. Then Ethernet 1/2. Ethernet 1/2 is my layer 3 interface, of course, virtual router. Default, I will create a separate zone, outside, okay. IP configuration, IP address 192.168.101/24, and 192.168.1.1 is the IP address of next hop device gateway basically. All right, so both configure. Let me drag and drop security zone so that we can see here. Adjust columns, looks good. Virtual router for internet connectivity, there should be a default route, right? Static route, add. So this is internet route. Internet route is means destination, any network address, any subnet mask. Exit interface, Ethernet 1/2, next hop IP address 192.168.1.1. 1.1 is my local internet gateway router IP, internal IP. Gateway means edge router has two IPs, internal and external. All good. And even I want to create a security policy here so that and I'm going to allow like all traffic, because objective is not to understand firewall security rules or firewall policy, VPN, right? So source zone, inside, and source address, anyone from my internal network address. So source address, anyone from 10.1.1.0/24. All right, destination zone, outside, destination address, any application, any service, any action is allowed. Good. Okay. So firewall security policy is also created. What about the NAT policy? Let me create one source NAT policy. Source NAT policy. Original packet, source zone, inside, destination, outside, source address, 10.1.1.0, 10. I'm sorry, 0/24, and translated package source translation with interface IP, Ethernet 1/2, external, and finally commit changes. So initial configuration, basic configuration of Palo Alto Firewall is successfully done. So let me wipe the configuration if there is any prior configuration and start. I will check internet connectivity reachability from this computer because now this Palo Alto Firewall has a default route. Default route is pointing to next hop device, and basically there is a router here, and router internal interface IP is 192.168.1.1, and external interface is public IP address .99. Okay, so for Palo Alto Firewall, next hop is 192.168.1.1. For a computer behind Palo Alto Firewall, gateway would be 10.1.1.1. Firewall has now default route security policy that permits all traffic, and also source NAT policy, right? And interfaces properly configured with IP, security zone. That means very much like firewall is now live. Firewall will start routing traffic to the internet from any device, like from the internal LAN site. We'll do that testing, right? This machine is booting up, and let's see what is the status of virtual network gateway in Azure cloud. It's been very long time, so most likely uh, like maybe finished or about to finish. So deployment is in progress, so still it's going on, right? Minimum 30 to 40 minutes, right? So in the meantime, I'm going to test internet reachability from Windows computer that is behind Palo Alto Firewall. Here. So network and sharing center will have to first assign IP address, subnet mask, gateway, and DNS server. So local area connection, properties, on 10.1.1.2, 255, 255, 255, gateway 1, and DNS server. So I'm going to ping any internet IP 888, for example, and if firewall is connected with internet, yes, and we can also verify with traceroute command, traceroute -d 888. So first my Palo Alto firewall, that is 10.1.1, then edge router, and finally to ISP and other internet routers. So all good. So Palo Alto firewall has been successfully now configured, connected with internet. Both interfaces configured. There is one default static route, source NAT policy, and firewall policy. And that's what minimum configuration is about firewalls. So since we do not want to restrict traffic, so we created a firewall policy to permit all traffic. Okay, we can also do testing to using any website, in fact, like facebook.com, even like it's a virtual machine, so very slow, but you can see now facebook.com successfully opened. Okay, all right. And virtual network gateway is also successfully deployed now. Go to resources. So here, like we have option to create connections under settings. So configuration, connections, point to site, and also site to site. That's what we want to configure. So both like local gateway and virtual network gateway, both gateways now successfully created. So if I go to this connection option, and it's connection, not basically configuration, right? Connections, add, and on this page, if you look at different tabs, then the first tab is like we are creating a connection. So basically last step. Okay, so let me make a correction here. IPsec tunnel configuration is done from where, like creating a connection, create a connection under settings. All right, so on this page, if I select here site to site IPsec VPN, right, other options like VNet to VNet and express route. Okay, so IPsec site to site VPN, and next tab, and also give a name, IPsec tunnel 101, resource group, connection type, name, and reason. Settings. On this page, right, on this setting page, by default, IKE and IPsec policy is set as default, right? Default encryption method, hashing method, DH group, lifetime, right? Except like the shared key, pre-shared key used in VPN peers authentication. So can we do customization here? Can we set like our own IKE and IPsec parameters, phase 1 and phase 2 parameters? And what about this connection mode? So both like possible. If you click here, custom, now look at option here, IKE phase 1 can be customized. Phase 2 parameter known as IPsec, yes, can be customized. Lifetime, dead peer detection timeout, you can do customization here. But what if you go with this default option? So by default, phase 1 and phase 2 parameters are selected, right? But how would we know like what has been selected? In the configuration file, when we download configuration file, so in configuration file we find all accepted selected rather I would say security attributes. Okay, DPD also I can see here, dead peer detection, connection mode, default initiator, a responder, right? Default, if you want to go with maybe if you want to make this gateway as initiator or just responder only, right? So on this page, like we can do little configuration and that's it, right? No other configuration required here. And is the last step. So first what we did, we created virtual network gateway object, took approximately 30 to 40 minutes. Then local network gateway to represent on-prem VPN gateway, name is like local internet gateway, confusing name, could have been like remote gateway even, right? And the third step is creating connection, is part of IPsec configuration. So select here your virtual network gateway, local gateway, and pre-shared key, and IKE protocol version. Version 1 or version 2. Version 2 is the default version. If you want to enable border gateway protocol, you can do that. Not, then you can leave other fields blank. So I'm going to select my Azure VPN gateway and Palo Alto gateway. Both gateways selected here. Okay, and shared key. I will use shared key as network cloud. Network cloud. And let's say I want to go with IKE version 1. Right? Review and create. Done. So virtual network gateway, local network gateway, and then IPsec connection. Once connection is created, then final step would be downloading configuration file. Okay, and rest of the configuration we'll do on Palo Alto Firewall. But before that, we need configuration file because we selected default option, not custom. Okay, so default means encryption method, hashing method, DH group, lifetime, all must have been chosen by Azure. We'll like find like those parameters attributes in configuration file. So I'm just waiting and will not take much time because this is the final step. So just matter of a minute or maybe maximum a couple of minutes, not more than that. Virtual network gateway creation takes very long time. Okay, 30 to 40 minutes. So whenever you are creating your own lab infrastructure, so if even taking longer time, maybe 40-45 minutes, so don't cancel, just you have to be very patient. In fact, just wait patiently there, because if there is poor internet connectivity, slow internet connection, so take like much more longer time. So there are like some resources in Azure cloud takes much time, in fact, when we deploy like those resources. So IPsec tunnel is created, and the last step, download configuration, right? So click here to download configuration file. So choose a device vendor. I don't see Palo Alto Firewall listed over here, no problem whatsoever, because we know like how to configure Palo Alto Firewall. What we require here only parameters, security attributes. So literally I'm not bothered with like the vendor because I'm not going to do copy and paste, in fact, and copy and paste even doesn't work. Select any like ISR or ASR router and firmware version. Even here, like I don't see IKE version 1, but no worries, right? So select Cisco and Cisco ISR because Palo Alto is not listed here. Very short list, and click here download configuration, right? So I will name it VPN config file, config file, save, and open. So now I have like all the information. I can see here public IP address of Azure cloud. I need public IP and other informations just to for reference, not required here. Virtual network address, CIDR block, cloud site, net mask. Yes, we know that. Local gateway, on-premises gateway. Okay, so these informations not required. IPsec IKE parameter, IKE version 2, and the encryption method, integrity, DH group, and lifetime, and pre-shared key, of course. So all required here. Just get rid of other configuration. So this is basically my IKE crypto or IKE phase 1 security attributes. Security attributes. IPsec means like your IPsec crypto or IKE phase 2. IKE phase 2 is data plane tunnel for user traffic, right? Phase 1 is never used for data plane traffic. Phase 2 is used. So ESP, encapsulating security payload, is the IPsec protocol AES 256 and SHA 256 here. PFS, perfect forward secrecy, is disabled, and in Palo Alto Firewall by default PFS is enabled. So uh, make a note of it. Lifetime 3600 second. KB not required here. Do we have to configure border gateway protocol? No, we will do static routing. ACL not required because we are doing route based VPN. What other information we need here? Commands, Cisco style. No, we don't need. It's public IP address. So 140 already is in the file. 140 VPN side IP. So even I can delete everything from here. Not required. IPsec transform said no. What I need now, tunnel interface, tunnel is created, and tunnel interface IP 192.169.254.0.1. MSS is here, maximum segment size, not mandatory though, but recommended just to avoid fragmentation. Tunnel source, tunnel destination, not required in Palo Alto Firewall, but MSS, yes, we can set MSS or MTU is 1350. Tunnel interface IP, even not mandatory, but we can configure, no issue at all. Tunnel configuration. So it's a tunnel interface IP, and that's it. So what I need, like public IP address of Azure VPN gateway, phase 1 parameter, phase 2 parameter, and tunnel interface IP, right? So I can now delete other configuration. Okay. Simple. So I'm trying to keep it simple. Done. So I need public IP, phase 1, phase 2, and tunnel interface IP. Right. All right. So I'm back to this Palo Alto Firewall configuration. And first step is creating a tunnel interface. Tunnel interface, right? So network, and just increase the font size so that you can see properly. Create tunnel interface. You can give any number. Virtual router is a layer 3 interface. Security zone. Strongly recommended to put tunnel interface in a separate zone. So I will create a new zone for tunnel interface. VPN zone. So VPN zone is created. Interface IP not required though, but I can assign 169.254.0.1 slash 30, two IPs, 1 and 2 maybe Azure side. And why tunnel interface IP address is not mandatory in Palo Alto Firewall? Because we are going to do dynamic routing. If dynamic routing you have like plan to configure dynamic routing, then yes, tunnel interface IP address would be required. If you want to go with the static or default route, tunnel interface IP address is optional. We can configure routing with just exit interface as the tunnel interface. So even if you don't assign tunnel interface IP address, no problem. And why like a PIPA? Because a PIPA is link local address, non-routable, right? Link local address. Directly connected interfaces, yes, they can be assigned IP. And you must have seen in Windows platform also, if there is no static IP configuration, there is no DHCP server, so Windows-based computers automatically assign IP address from the same class B network range, any IP, but initial two octets 169.254, and then third and fourth octet any number from 02 to 55. A PIPA, automatic private IP address. And so why Azure has used the same address space? Because a PIPA is something link local address, non-routable address, right? So IP cannot be routed. Okay. Hit down OK. Tunnel interface is created, and now I'm going to create a default route, not default route, a route for Azure Virtual Network. All right. So what I have to do, I'll have to select the virtual router and static route. I don't have any plan of BGP. So this is Azure Virtual Network route. So how to get Azure Virtual Network 0.0/16. So interface would be tunnel interface, tunnel 1. What about the next hop IP address? Even if you select none here, no next hop IP address, no problem. However, next hop IP address would be, I believe, 169.254.0.2, the next available IP address. Okay, routing part is done. So Palo Alto Firewall side routing part is done. Next, like IC and IPsec configuration, phase 1 and phase 2 configuration. In Palo Alto, phase 1, for phase 1, we create iCrypto profile. iCrypto is about phase 1, right? So this is iCrypto profile, crypto 1. DH group 2, authentication, SHA-1, encryption, AES 256, lifetime 3600 seconds. Just do a quick verification. All like selected parameters correct or not. AES CBC 256, SHA-1 to 3600 second, network cloud is this. And what about the public IP address of VPN gateway? 20.163.178.140. Done. So, and where do we define local and remote gateway IP in iGateway? So next configuration I'll be doing here iGateway 1 interface, my external interface Ethernet 1/2, local IP 192, peer IP address. Peer IP means Azure Virtual Network Gateway address, right? Virtual Network Gateway address, VPN gateway IP in Azure Cloud. Pre-shared key network cloud. Probably I typed wrong password. No, network cloud, and then go to advanced. DPD is enabled, exchange mode did auto, looks good to me. And here just select your profile iCrypto, right? Passive mode, NAT traversal, even you can enable NAT traversal. All right. IPsec crypto phase 2. So IPsec crypto is basically your phase 2. IPsec crypto 1. ESP protocol, yes, we don't want to go with AH protocol because ESP is selected by Azure, chosen by Azure. Encryption method, we will have to verify. Encryption is AES 256, SHA 256, PFS disable, and 3600 time. 3600 seconds means an hour. AES 256, AES 256, I believe CBC, authentication SHA 256, DH group, no PFS means like no DH computation in phase 2, and lifetime is good, I believe 3600 seconds means an hour. Yes. And finally, IPsec tunnel. So in IPsec tunnel, like we associate both gateway and crypto profile. So this is my IPsec tunnel. All right, tunnel interface, iGateway, IPsec crypto, and the proxy ID is not required. Okay, and commit the changes. We'll do testing, but before that, let's quickly spin up a virtual machine in cloud also. So I'm going to spin up Ubuntu Linux virtual machine because we'll take less time as compared compared with Windows virtual machine. So I will spin up here Linux virtual machine. Resource group, virtual machine, Linux 1 or server 1, no infrastructure, standard, Ubuntu 20.4, password, username, show admin, password, sorry. Alright, next in networking section, I will select private subnet, right? And by default, private subnet is selected. Why? Because gateway subnet has a VPN gateway, right? And in VPN gateway or in gateway subnet, we cannot spin up any other resource because dedicated subnet required. That is why. Review and create. So virtual machine is getting spinned up in Azure cloud, right? Just for the testing purpose, verification purpose, because objective is to check end-to-end IP reachability. IP reachability between on-prem Windows computer and Linux machine, like spinned up in Azure cloud. Look at this diagram again one more time. So we have spinned up Linux machine here, and first available IP is .4. So most probably, like private IP address assigned to virtual machine 1 would be 172.16.2.4, and Windows 7 computer behind Palo Alto Firewall 10.1.1.2. So we want to verify IP reachability between these two end host devices with private IP secure communication via this encrypted tunnel, protected tunnel protected with IPsec, right? So virtual machine is getting spinned up. In the meantime, I'm back to this Azure and not Azure on-prem. Let me open this Palo Alto Firewall CLI. So I have access Palo Alto Firewall, and what's the status of virtual machine? Successfully spinned up. So also I'm going to access Linux machine with Putty software. This public IP address, copy, paste. Accept username, Azure admin, and password. All right. So it's Linux machine, and also I have accessed Palo Alto Firewall, and also let me modify network security group so that, because by default incoming SSH is allowed, so I'm going to allow ICMP, right? Ping traffic with security group is getting created now. All right, so Palo Alto Firewall, in Palo Alto Firewall, even we have command like test VPN IK SA, test VPN IPsec SA, show VPN IK SA, security association, and I can see here phase 1 and show VPN IPsec SA phase 2. I can also see phase 2 here successfully created, right? And what about communication? Ping 172.16. 2.4. 2.4 is IP address of Linux virtual machine in Azure cloud. So not pinging, right? 172.16.2.4 not pinging. Let's do troubleshooting, right? Tunnel status is green. Phase 1, phase 2 both are up. So when we initiate it, connection from like Palo Alto Firewall itself, so both VPN ISA phase 1 looks good to me. IPsec SA phase 2 is also up, right? So problem here is like if traffic is coming from internal network site hitting firewall, not getting through, right, not passing through. But if we initiate traffic from Palo Alto Firewall itself and here like Azure VPN gateway, Azure, then successfully both tunnels are negotiated, right? And let's check from other side, from cloud to the this Windows machine, means from here virtual machine to Windows server this way. And there is no issue with the security group because already we have modified default network security group. So if I try to ping 10.1.1.2, 10.1.2 is the server machine like Windows 7 computer behind Palo Alto Firewall. No, there is no communication between both end host devices, but gateway to gateway, there is proper connectivity. So I believe either routing or maybe security policy issue, right, in Palo Alto Firewall. But before we start doing further investigation and troubleshooting, let's check status of Azure portal. So Azure portal, because there is no issue with network security group. Now ICMP is allowed, inbound ICMP is allowed. Even there is no issue with phase 1 and phase 2 attributes because test VPN, IKSA, IPsec both were successful. No issue with VPN security attributes. It's mainly 99% because of security policy rule in Palo Alto Firewall. But before we check security rule and make some changes, let's check the status of VPN tunnel from Azure portal, virtual network gateway, and what is the status of tunnel connections. And yeah, good, connected. So there is no issue with IPsec VPN configuration, right? So let me quickly go to Palo Alto Firewall. Tunnel status is up. So what about security policy? We have just created a security policy in Palo Alto Firewall. And yeah, this is the problem. So problem is with the security policy. We have just allowed traffic in only one direction, from inside to outside, right? Not between inside and VPN zone. So ideally, there should have been two security rules here. One, like to allow traffic outbound direction, means from inside zone to is my Palo Alto VPN zone, right? VPN tunnel interface is in VPN zone. And another security rule to allow traffic in reverse direction from VPN to inside zone between both networks like 10.1.1.0 and 172.16.0.0. But our objective is not to understand security policy in detail. So what I'm going to do, I'm going to just modify existing rule and I'll select source any, destination any, even source address any, destination any, because outside zone means like only external physical interface. We have put tunnel interface in VPN zone. right? So security rule now modified, all traffic allowed irrespective of zone and address. Of course, in production network, you should be very specific. You should create proper security rule, right? And commit. And once commit is successful, 100%, then we'll again test IP reachability between both end host devices, right? And should be successful, of course, because already we have tested IPsec configuration with test VPN command on Palo Alto Firewall. Even we have also verified from Azure portal, and it's being committed. And let me also show you routing table, right? So select network interface card of Linux Windows machine. We haven't done anything in routing, Azure portal side, but policy based routing, that means there should be route in the routing table, and route should be like to on-prem network, that is 10.1.1.0/24, and yeah, here we go. There is a route here, right? Address prefix 10.1.1.0, virtual network gateway, and public IP address, right? Route is automatically created. Okay, so Azure side, even routing is done automatically. You don't have to put any route. Route is propagated in the routing table. On like Palo Alto Firewall side, yes, routing is static or maybe BGP is to be done by the administrator. So Azure portal side, there is like nothing very complex, really, only 3 steps. So once like commit is successful, then we'll do this testing, and yes, is pinging. That means commit has been successful now, and I can easily communicate with Azure virtual machine with private IPs here. 2.4 is what? Azure virtual machine IP. If you want to verify private IP address, so let's back to this networking section and private IP address as we expected 2.4, because dot 4 is the first O-level IP address. 5 IPs per subnet reserved in Azure cloud 0, 1, 2, 3 and 255. So dot 4 is the first O-level IP address. Can we also test from Linux machine? And yes, it's pinging now, right? You can do it again. Ping 10.1.1.2. And further, if I show you commit is successful, networking tab. So if you click terminal info, then we'll see like packets encapsulated, de-encapsulated, right? Successful. Also, we can check like session browser under monitoring tab. System also like will show phase 1 and phase 2 negotiation, right? Phase 2 and phase 1 negotiation. IPsec key installed successfully, and if I go to session browser, then will show like here traffic moving back and forth between these two devices, end host machines. 10.1.1.2 like inside to VPN zone, and 172.16.2.4, and yes, ping traffic. Good so far. So really it's not very complex. Just you will have to be careful when like configuring on-prem VPN gateway. Azure side, no like big deal. In fact, very straightforward configuration. But on-prem side, yes, configuration wise, like you'll have to be careful. From here also you can see like IPsec phase 2 tunnel, data plane tunnel, user traffic tunnel, right? Phase 2 tunnel between your on-prem like Palo Alto and Azure VPN gateway. So that's all for this session. I hope you now understand how we can set up RPsec tunnel between on-prem VPN gateway and Azure VPN gateway, right?